In this video, I will teach you how to find the derivative of an inverse at a point. If you appreciate the content, please give it a like. Inverse functions are reflections of each other over the line y equals x. If this is the function f of x, f inverse is written like this with a little -1 superscript. Or sometimes they just tell you the function g of x is the inverse of f of x. We know that f prime at 2 means the slope of f at 2, the slope of this tangent line. Similarly, f inverse prime at 2 will be the slope of this tangent line. On some problems, they would call this g prime at 2, where g is the inverse. If you are a formula person, here is the formula for the derivative of an inverse at a point. In this case, I prefer to think of it as a three-step process instead of a formula. So I'm going to demonstrate my three-step process for finding the derivative of an inverse at a point. For this first example, we are given three pieces of information, but then we are asked to find f inverse prime at 6, the derivative of the inverse at 6. From this point forward, whenever you see that you are being asked to find the derivative of an inverse at a point, you should be thinking, oh, this is that three-step process. The first step is to find the inverse without the derivative. So ultimately we need to find f inverse prime at 6, but the first step is to forget about the prime and just find f inverse at 6. In AP Pre-Calculus, we learned that to evaluate f inverse at 6, you ask yourself f at what is equal to 6? Well, we are given that f at 4 is equal to 6, so f inverse at 6 is 4. Step 2 is to find f prime at your answer to step 1, so f prime at 4. f prime at 4 is 2/3. Step 3 is to write the final answer. f inverse prime at 6 is the reciprocal of step 2. So 3/2. And that's it. Sometimes they give you a bunch of information in table form, and it's your job to pick out what you need. Selected values for the functions f of x and f prime are shown in the table below. Let g of x be the inverse of f. Part A. Find g prime at 3. Remember, g is the inverse, so this is the derivative of the inverse at a point. Whenever you realize that you are being asked for the derivative of an inverse at a point, it's the three-step process I just taught you. Step 1 is to take away the prime and just find the inverse at 3. In AP Pre-Calculus, we learned that to evaluate the inverse at 3, you ask yourself f at what is equal to 3. On the table, we can see that f at 4 is equal to 3. So the inverse at 3 must equal 4. Step 2 is to do f prime at the value you just found in step 1. According to the table, f prime at 4 is 2. So that's it for step 2. For step 3, you write the final answer. G prime at 3 is simply the reciprocal of your answer from step 2. So that's the three-step process for finding the derivative of an inverse at a point. Let's do it again. For part B, we need to find g prime at 4. Step 1 is to take away the prime and find g at 4. To find the inverse at 4, you ask yourself f at what is equal to 4. On the chart, we see that f at 2 is equal to 4, so the inverse at 4 must equal 2. Step 2 is to find f prime at the answer from step 1. On the table, we see that f prime at 2 is 3. In step 3, we can write the final answer, g prime at 4, which is the reciprocal of the answer from step 2. Let f be the function defined by f of x equals the square root of x minus 4. If g of x is the inverse of f, what is the value of g prime at 2, the derivative of the inverse at a point? So it's going to be the 3-step process again. Step 1 is to take away the prime and find g at 2, the inverse at 2. In order to find the inverse at 2, you ask yourself f at what is equal to 2. Since we have an equation and not a chart, let's go ahead and put a variable in here. So we need to solve the equation f at x equals 2 for x. F of x is the square root of x minus 4. So this equation becomes the square root of x minus 4 is equal to 2. We can get rid of the square root by squaring both sides of the equation, which will give us x minus 4 is equal to 4. Adding 4 to both sides, we get x is equal to 8. So that's the value of the inverse at 2. Step 2 is to find f prime at your answer from step 1. Since we don't have a table, we have to find f prime ourselves. Let's think of f of x as x minus 4 to the 1/2 power. Now we can find f prime of x using the power rule. We will bring the 1/2 to the front and reduce this exponent by 1. I think this will be easier to follow if we rewrite f prime. The 2 from the 1/2 will be in the denominator, of course. Because of the negative exponent, this whole expression will drop down to the denominator. So I'm going to temporarily write x minus 4 to the positive 1/2 power. But of course the 1/2 power is the same as square root. So f prime of x is equal to this expression. We need to find f prime at 8. So let's plug in 8 for x. 8 minus 4 is 4, and the square root of 4 is 2. So this is 1 over 4. And that's it for step 2. Step 3 is to write the final answer. G prime at 2, the derivative of the inverse at 2, is the reciprocal of the answer from step 2. That's 4. That's it. Let's put a little box around it to make sure they know this is the answer. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.